Hello friends. In this video, we're going to write a small C++ program that calculates simple interest. But before we touch any code, let's get the idea straight. Simple interest is just a formula. You take the principal, the money you started with, multiply it by the rate of interest, multiply that by the time, and divide by 100. That's it. Principal times rate times time, divided by 100. Now here's the interesting part. When you punch this into a calculator, it feels instant. When a computer does it, it's even faster. The CPU runs these multiplications and the division in a few nanoseconds. So really, we're not teaching the computer anything clever. We're just translating a school formula into a language the machine understands. Let me show you how. Alright, let's set up the skeleton. At the top, we include iostream. That's the standard header that gives us input and output. Without it, the program can't read from the keyboard or print to the screen. Next, we write using namespace std. This is a small convenience. The C++ standard library lives inside a namespace called std, and this line tells the compiler we'll be using it, so we don't have to write std::, in front of every cout and sin. Then comes int main. This is where every C++ program begins. The operating system looks for main, runs whatever is inside the curly braces, and when it hits return 0, the program ends cleanly. The 0 is just a signal that says everything went fine. So this is our empty stage. Now let's put the actors on it, the variables and the input. Now the real work begins. First line inside main, we declare 3 float variables: principal, rate, and time. Why float and not int? Because interest rates and time periods often come with decimals. 5.5%, 2.3 years. If we used int, the decimal part would just get chopped off, and our answer would be wrong. Now look at the next few lines. Cout sends text to the screen. It's how the program asks a question. Sin does the opposite. It waits for the user to type something and stores it in the variable on the right. So when we write sin greater than principal, the program pauses, the cursor blinks, and whatever number the user types gets parked in the principal variable. Same thing for rate and time. Under the hood, each of these floats is just a small block of memory holding the number. Once all 3 are filled, we're ready to do the math. Here's where the formula finally shows up. We add one more float called interest to hold our answer. Then this one line does all the work. Interest equals open parentheses, principal times rate times time, close parentheses, divided by 100. The parentheses force the multiplications to happen first, then the division. This matters. If we wrote it without the parentheses, C++ would still mostly do the right thing because of operator precedence. But writing the parentheses makes the intent crystal clear, both to the compiler and to anyone reading the code later. Behind the scenes, the CPU grabs the 3 float values from memory, runs the multiplications, divides by 100, and stores the result back in interest. All of this in a fraction of a microsecond. Then the last cout prints the answer to the screen. Principal of 1000, rate of 5, time of 2, gives us 100. The formula worked. The program works. So let's zoom out. What did we actually build? 3 steps. We read 3 numbers from the user. We ran 1 line of arithmetic. We printed the answer. That's the whole program. And honestly, this shape, read something, compute something, write something, is the skeleton of almost every program you'll ever write. Whether it's a calculator, a banking app, or a machine learning model crunching billions of numbers, the pattern underneath is the same. Input, process, output. The formula changes, the scale changes, but the shape stays. Try this program yourself. Change the numbers. Try a rate of 7 and a time of 3. See what comes out. Play with it. That's how the logic really sticks. If this helped, hit that like button, subscribe to Webronaq for more, and drop a comment if you want me to cover compound interest next. See you in the next video.